to the Learner's Planet. So students, in this session we will solve questions of chemistry paper of 2011, right? So this will be our first problem solving session, right? So let's start solving questions, students. Now this is a very first question. So these are the questions which were there in the chemistry paper of 2011. Okay. Now there is a question over here, students, that among the following, the maximum covalent character is shown by the compound. Right. Now students, as soon as you just go into such sort of questions where the covalency or the ionic character of a compound is asked, do remember Fajan rule. Right? Just recall that Fajan rule. What was Fajan rule? Fajan rule states that the smaller is the size of the cation, what it does, it causes the distortion in the anion. Right? That is, your cation causes the distortion in anion and tries to pull up the outer electrons towards itself. Right? Thus, changing an ionic bond into a covalent bond. Say for example, I'll tell you here that if this is your cation, any cation I can write, this may be your Li, right? Li plus, and I have got a big anion, that is your LiCl or the Cl anion. Now students, what it will do, this cation causes distortion in anion, right? What is it is doing? Right? Now anion size is bigger. Now what it tries to do is, in cation and anion, say in an ionic bond, what happens? That there is complete transfer of electron. Now what this cation tries to do is, it tries to pull the outer electrons towards itself. Right? Now it can't pull it completely. Now this particular bond, which was ionic, becomes what? Covalent. Now this is your Fajan rule in simple words. Now see, let's take up now to find out which of the following is ionic in nature. Let's take up the sizes. Say your SnCl2, what is the cation over here? Sn2 plus. AlCl3, what is the cation over here? Al3 plus. MgCl2, what is the cation over here? Mg2 plus. Likewise, in FeCl2, what is the cation, students? It is Fe2 plus. Right? Now, of these cations, the one which has got the smallest size. Now see, you must be knowing that as the positive charge on an atom or on an ion increases, its size decreases. Right? Say, I can write here that as the charge on ion or cation increases, what happens, students? Their size decreases. Right? Do I need to explain this? What happens in a cation? The number of protons is more than the number of electrons. Right? So what it does, the protons pull the electrons towards itself, thus decreasing their size. Right? Now, see here, And along the group, what happens, students? From top to bottom, the size of the atom increases, and along the period from left to right, the size of the atom decreases. Now see, in this case, which is the smallest cation? Al3 plus is the smallest cation. Tin, where it is present? Tin is present in the group of carbon, that is carbon, silicon, germanium, tin and lead. So students, it is present in 6th period, in your 5th period, right? Now what happens? Down the group the size increases, so the size of tin is more. And where is your aluminium? Aluminium is present in the 3rd group. Getting my point? Now we have got boron, aluminium, gallium, indium and thallium. So aluminium is present in your 3rd period and 3rd group. Right? Now students, whose size will be smaller? Aluminium. Then what all other things we are having? Magnesium, it is an alkaline earth metal, and of course its size is bigger than the aluminium because it is present in the 2nd group. Iron, it is a transition element, its size is bigger. So which has got the smallest size? Aluminium. Which will cause maximum distortion in anion? Aluminium. So which will have the maximum ionic character? AlCl3. So this is our option. Now students, while just working on this problem, just keep 2 things in mind. First of all, the size of the cation and anion. The one which has got the smallest size will have maximum covalent character in case of cation, and in case of anion, the one which has got the largest size will have the covalent character. Right? So you have to remember this Fajan rule and of course the sizes. Do remember that on moving from left to right in the periodic table, the sizes decrease, but on moving from top to bottom, the sizes increase. Right? So this was actually a very simple question. You know, in your this AIEEE paper or AIPMT, what happens that there are simple questions. There's the application based questions. It's just that you should know the basics, your basics should be clear. Right? Let's take up our next question, students. See, the question over here is, this is from your biomolecules, the paper, the topic which students normally leave. But you know, from that topic very simple questions come. The presence or absence of hydroxyl group. The presence, or it should be or over here. The presence or absence of hydroxyl group on which carbon atom of sugar differentiates RNA and DNA. What is RNA? It is ribonucleic acid, right? And this is deoxyribonucleic acid. Deoxy. At which position the hydroxyl group is lacking? I'll draw the structure over here, students. See, this is O. And what type of ring is this? It is, it goes like this. It is actually a pentose sugar, right? Your ribose and deoxyribose, they are pentose sugars. Okay? Now this, we have got one CH2OH over here. So this is your, this carbon is first carbon, your second carbon, right? So in DNA there is no hydroxyl group at the second carbon. Whereas if I draw the structure of RNA, that is your ribose sugar, what is there? We have got hydroxyl group at the second carbon atom. This is OH over here, right? This is again OH, H, and here we have got CH2OH. Now to the first carbon atom, a nucleotide is bonded, right? And to the third carbon atom there is a phosphorus group. Remember its structure, students. This is the first carbon atom. This is what? This is DNA, that is deoxyribonucleic acid, right? Deoxyribonucleic acid. And what is this? This is ribonucleic acid. Right? Now, to add the first carbon, what is bonded? At the first carbon there is nitrogen base. In both the cases, nitrogen base like purine, pyrimidine, right? And at the third carbon there is a phosphorus group bonded. That is phosphate. There is 3,5-phosphodiester bond is present, right?